Here we've got a piecewise defined function. That just means that our function is not defined by one rule. It's defined by multiple rules. Those rules are broken up according to which piece of the domain you're looking at. So what x values you're plugging into the function. So what that does to the graph is it breaks it up into pieces. Our major x values where we're breaking up the domain are at x equals -1 and x equals +1. So I'm marking those 2 points on the graph. And then the first rule is the y value is -1 if x is less or equal to -1. So I'll start at x equals -1, and I want to draw a flat line at y equals -1 going out to the left. I'm using a closed circle there at x equals -1 because in the rule it said less or equal to. If it didn't have the equal sign under the less than, I would put an open circle instead of a closed circle. For the second piece, we've got the function x squared. And we're only doing that one from -1 to 1. It's not equal at -1, so we'll put an open circle there. It is equal at +1, so put a closed circle there. And then I'm already familiar with the graph of y equals x squared. I know the vertex is at the origin. So I've quickly sketched that piece of the parabola from -1 to 1. And then the last piece is for x greater than 1, and then the y value is equal to -x. So if you plug in x equals +1 into -x, you get -1. So that's the y value when x is 1. Since there's not an equal sign under the greater than for that third rule, that third piece, I'm using an open circle. And then I know I've got a slope of -1. So I know exactly how that graph decreases. Now, second, we're told to give the intervals over which the function is increasing, decreasing, constant, and continuous. If you look at this graph, it's only increasing from x equals 0 to x equals 1. Everywhere else, the y values are either constant as you move from left to right, or they're going down. It's decreasing from x equals -1 to 0, and also from x equals 1 out forever to the right. And then it's constant only on the part where there's a flat horizontal line where the y values are all -1. And that's from -infinity out to x equals -1. And it's continuous everywhere except where there's a break in the graph. So I'm going to throw out x equals -1 and x equals +1, but everywhere else, this graph is continuous. So I'm going to have 3 pieces, and I'm just going to join them together with little union signs. And that last part that you can barely see just says 1 to infinity. And finally, we're asked to evaluate f of 1/2. So to get this, you plug in x equals 1/2. And this is broken up into 3 rules, so which rule do we plug in x equals 1/2 into to get the appropriate y value? It's the second rule, because 1/2 is between -1 and 1. So you plug in 1/2 into x squared, and 1/2 times 1/2 is 1/4. Remember, you multiply fractions by multiplying straight across. Multiply the numerators, multiply the denominators. So 1/2 squared is 1/4, and that finishes up that problem.